So let's take a look at how we would graphically evolve our convolution integral. So I've copied our simplified convolution integral from our previous video. So we have y of t equals x of t convolved with h of t, and then we have this integral with our updated limits of 0 to t. So of course we're going to assume we have graphical representations of the two functions we want to convolve. So in this case x of t and h of t. And so if we have those two graphical informations, then we're just going to follow the steps here. So our first step is going to be something called folding. And so what this is we're going to take the mirror image of our h of lambda. So take mirror image of h of lambda. Notice I've already put in this dummy variable instead of the t that we had up here. And so all that is just switching the name of our independent axis. And so we're taking the mirror image of h of lambda about the y-axis. And so what that gives us is h of negative lambda. So that's our folding step. Our second step is our displacement. So in our displacement step, what we're doing is we're shifting our h of negative lambda by a value of t. So shift h of negative lambda by t, and what that gives us is our h of t minus lambda. And so of course you can kind of see where we're going. We're getting this in the form that we have here. So our third step is then to just multiply and integrate. So multiply and integrate. And basically here we're having to look at given time t. So I'll come back and make a note about that in a second. But let's just say for a given time t, what we want to do is calculate the product. So calculate the integral of that product of x of lambda, so x of lambda times h of t minus lambda. And so what we have to do, if we sort of focus on, well, what's for a given time t, what we're really doing is we're sort of scanning this shifted, displaced version of our h across different t values, and we're seeing how it changes. So we're scanning our h of t minus tau as our t value is changing. And so that's it. So we're basically then, that third step is just finding this product and then taking the integral. And again, by scanning, we're accounting for different time intervals t. And so I know this is kind of difficult to sort of wrap your head around. So what we're going to do in the next video is we're going to look at a relatively simple example of doing this type of graphical convolution.